A perfect day turns deadly. The Boston Marathon bombing.
Explosions near the finish line.
Investigators go into high gear to find the suspects, but there's a twist. It's a new age of counterterrorism technology, with electronic eyes on the streets.
We knew we'd get good video.
And in the skies.
You can't fool a thermal picture.
And computers that build faces.
The computer has to hallucinate.
New tools in the detective's arsenal. There's an avalanche of evidence.
That white smoke, what does that mean? There's chemical evidence. There's visual evidence.
A torrent of information, unfiltered, unedited, and often wildly inaccurate.
There was an information vacuum. People were filling it with bad information.
The FBI didn't know who these suspects were.
But somewhere hidden in the chaos are crucial clues. Can technology help investigators find the truth and track down the perpetrator?
It was terrifying. We were shaking.
Manhunt, Boston Bombers, right now on Nova.
Major funding for NOVA is provided by the following. The David H. Koch Fund for Science, supporting NOVA and promoting public understanding of science. The Corporation for Public Broadcasting, and by contributions to your PBS station from viewers like you. Thank you.
It is Marathon Day in Boston.
I went off in the first wave. It was a beautiful day.
The weather is perfect.
It's a special day, you know, the atmosphere is just electric.
Thousands line the streets, enjoying the city's most celebrated sporting event. Among the runners, heading for the finish line in his 44th marathon, Boston Police Superintendent Bill Evans.
I felt great. When I get into Boston, I'm saying hi to all my fellow officers on the route. The ironic thing is, when I finished, the bomb squad was right there with a dog. That's something I remember, given the way the events of the day turned out.
An hour later, the unimaginable happens. 2 bombs explode within seconds, killing 3 and injuring hundreds. Almost immediately, the manhunt begins. Investigators will push the limits of technology with new tools, such as facial recognition, thermal imaging, and bomb analysis. The clock is ticking. Can they get the bombers before they strike again?
This vehicle might be heading towards New York.
There's gotta be people hurt.
Oh my God. Oh my God.
In the minutes after the bombing, first responders rushed to help.
We've just gotten word of not 1 but 2 explosions near the finish line of the Boston Marathon. These are live pictures coming into us now.
The horror plays out in real time on TV and social media.
These 2 explosions were heard near the finish line.
Clearly, this developing very quickly now, Shep.
It is, and we're just getting more now.
As we take a look at this is raw video just coming into the newsroom, and we feel that it's important to get it out there.
We are all in Boston, immersed in a chaotic scene.
And the police officers immediately have to rush over, and the confusion and chaos immediately.
The police and medics are rushing toward the danger of more explosions, just as many of them were trained to do by this man, Van Romero, one of the world's leading experts on explosives.
People gravely injured.
He watches with the heart of a friend and the mind of a scientist.
It's almost schizophrenic from my standpoint. part of my brain is going into analysis mode. Is there a crater? That white smoke, what does that mean? I started looking for broken windows. That tells me how big the pressure wave was. All that analytical stuff is going through your brain. At the same time, we know the people that are responding. They come here, they become our friends. We know how dangerous it is. It's emotional to watch those guys do their job.
Romero heads research at New Mexico Tech University in Socorro. The school operates the most active explosives testing facility in the U.S. Every workday, at least 2 or 3 explosions echo across 40 square miles of barren desert canyons here. It began as and remains a favorite place for weapons makers to measure the menace of missiles and ordnance. But in the age of terrorism, a new kind of client has beaten a path to Socorro. Name a crime of terror. Oklahoma City, the first attack on the World Trade Center, or the London transit bombings. After each attack, investigators have come here to test their notions of what happened as they built a legal case.
When you look at the scene of a terrorist bomb, it's just a mess. The important role that we play is how do we put the pieces of the puzzle together so that we know they fit?
But solving the puzzle and saving lives are often at odds.
They have to rescue people, stabilize the area, make sure they're safe, but also hopefully protect the forensic evidence that's left behind.
For Romero, the first clue is the smoke. It is white, a surefire sign of a gunpowder explosion. It means the devices are likely homemade. He wonders if they could be pressure cooker bombs.
Pressure cookers aren't as common here in the United States, although they are common in the Middle East.
Pressure cooker bombs are a tried and true instrument of terror globally. In 2006, Islamic terrorists set off 7 of them in 11 minutes on crowded commuter trains in Mumbai, India, killing more than 200. So what is a pressure cooker bomb?
It's a higher pressure. They go farther, easier to hide.
It starts with something you might have in your kitchen.
It's just a pressure cooker that you'd have in your home.
It is distressingly simple to build. The ingredients for the bomb are cheap and easily available. Gunpowder and shrapnel. In this case, some nuts still in their packaging.
And put the top on too.
The tightly sealed pot cooks food faster, but when gunpowder is ignited inside, it will burst. Ignition is the only complicated step. They didn't share that with us. But a simple how-to is not hard to find. So could an amateur build and detonate 2 of these bombs almost at once without any training?
The fact that they were 2 for 2 kind of indicates to me that it was a little bit more than luck. And the fact that they were so close together, 10 to 15 seconds away, is essentially simultaneous. To me, it indicates some level of sophistication.
The team here in New Mexico has that sophistication. When their bomb is ready, the warning siren sounds, and they retreat to a bunker high above the site, almost half a mile away.
Stand by for count. 5, 4, 3, 2, 1.
So you can see the smoke that came off is exactly what you saw in Boston.
The explosions are strikingly similar. What can investigators learn by seeing the explosion in slow motion? Here at New Mexico Tech, they can do that with high-definition, high-speed cameras at 6,200 frames a second, allowing the experts to examine in forensic detail how the bomb explodes.
It's okay, let's back it up.
We step through this video, we see what Mike was pointing out was first we get this jet coming right out the top of the pressure cooker.
Yeah, so it fails right where the top seals into the pot.
So you can actually see the flame in between where the latches were on the cooker.
Oh, yeah.
Placing the pressure cooker on its side directs the shrapnel closer to the ground, making the bomb more lethal.
So when the lid let go, the pressure cooker split apart and launched everything backwards.
So it peeled like a banana as it came out.
These pieces are the walls of the pressure cooker.
One of the fragments, which appears to be part of the sidewall.
The replay also allows the experts to determine the speed of the fragments.
It's moved almost 7 pixels. At our pixel resolution of 6 millimeters per pixel, that's about 270 meters per second.
Per second, okay,
that's
so
moving at.
So not quite the speed of sound, but it's moving pretty good.
By observing how fast shrapnel flies apart, forensics experts like these can gauge the size and power of an individual bomb. That's a valuable piece of information for investigators in Boston, who at this point still aren't sure what kind of device was used. With the injured evacuated, the forensic work begins in earnest. The FBI, ATF, and other federal agencies join the Boston Police Department and the Massachusetts State Police in the hunt for the bombers. It starts with a search for fragments of the bombs. This is exactly what they're taught to do here in New Mexico, where Van Romero leads a team of students to sweep the area.
Oh, here's some nuts, some plastic from the handle.
Walking shoulder to shoulder, they pick up everything they can find.
Oh, here's the lid from the pressure cooker. This is going to be a really important piece of forensic evidence. You find this and you go, okay, this was part of the device. And now that I know part of the device, I can analyze this metal and figure out what the brand, the model, the make of the pressure cooker, where the metal was forged, where this thing was manufactured. And then as I collect other fragments, I want to make sure that they match the origin of this piece here.
I'll dump some of these out so that we can take a look.
In the lab, engineer Mike Stanley combs through the fragments.
Even though you have a detonation, all of the pieces are still there. They've just been separated. So with enough time and enough diligence, you could actually put that entire pressure cooker back together. The evidence is all there. It's just in small pieces, and you have to find all those pieces.
In Boston, instead of nuts, they find BBs and nails scattered throughout the scene, the shrapnel from inside the bomb. And then, on the roof of a 6-story hotel nearby, they find a lid. It confirms Romero's hunch that the bombs were built from pressure cookers.
You never stop really trying to understand what's going on at the scene, and you have to make sure you've peeled back all the skin of the onion to understand what's going on.
Police Superintendent Bill Evans, who only 90 minutes before finished running the marathon, is now speeding back to Copley Square in his cruiser.
Get as many people up here as you can from the medical tent.
On the way there, the whole time I was hoping that maybe it was a gas explosion or an electrical explosion. And so the whole way there, I'm saying, it can't be your bombs. It can't be. Please don't let it be a bomb.
When he arrives at the finish line, he has no doubt that he is now at the center of a horrific crime scene.
I had just run down the street, probably an hour and a half before this, and it was such a festive occasion. And now to look up the street and see those young victims still laying on the street, and to see windows smashed, the barriers blown out into the street, debris everywhere, it was surreal. It looked like something we'd see over in Beirut or Israel. It was sad is what it was.
3 are dead, dozens maimed. Bill Evans is now on duty. His great run on a beautiful day shattered by a dreaded nightmare. In the chaos, his boss, Commissioner Ed Davis, has no doubt about what needs to be done right away.
We have a lieutenant here who does a lot of video collection for us. He happened to be right there as I arrived on the scene. So I grabbed him and I said, listen, first job here, get on the video. Start to pull video from all of the locations and let's start looking at it. And so within 10 minutes of the blast, we had detectives that were already out pulling video.
If you know Boylston Street, there's basically 200 businesses, stores on that street. So we knew we'd get good video.
Detectives must go door to door hunting for visual evidence, since the cameras are privately owned and individually monitored. Boston has only a limited number of cameras, and there is nothing tying them together. Each video will have to be collected and viewed separately, a laborious and time-consuming process. But what if the cameras could all be watched in real time at a central location? Amazingly, today there is only one city where this is known to be possible: New York.
2 trips were shot.
When it comes to technology, Police Commissioner Ray Kelly is a true believer and an early adopter.
We're big fans of cameras here. It's been a tremendous force multiplier, if you will, for law enforcement.
The city's ambitious effort to connect and monitor thousands of surveillance cameras has never been tried before. The result is called the Domain Awareness System.
This is the state of the art. It is the most sophisticated camera system that you'll see across the world.
Domain Awareness takes in a steady stream of data from license plate readers, environmental sensors, and 4,000 closed-circuit cameras, the vast majority privately owned. The city designed the system after carefully studying the extensive CCTV network in London and trying to improve on it.
The reason that this is state-of-the-art is because this shows officers in real time what's happening, rather than being useful mainly for post-incident investigations, as is the system in London.
911, where's your emergency?
The system is integrated with 911 calls, so possible terrorist activity is flagged, and detailed information about the address is displayed, as well as the location of nearby cameras, which can be called up live or rewound as far back as 30 days. It reads license plates in every lane of every bridge and tunnel coming into Lower Manhattan and compares them to terror watch lists. It is also programmed to automatically spot suspicious behavior, like unattended bags sitting on a sidewalk. And it can search through huge amounts of video data to find specific shapes, movements, or colors. Watch what happens when you ask it to look for people wearing red near the New York Stock Exchange.
It's really a matter of 1 or 2 seconds. If these cameras weren't all on one system, what you'd have to do is you'd have to go to a pole, retrieve the video data, and then each camera would have to be looked at individually by a person to pull out the red shirt.
This is exactly what is happening in Boston.
27,000 strong starting out from Washington.
And surveillance cameras are just part of the picture.
Everybody had cameras out that day. Everybody was taking pictures of their loved ones finishing at the finish line.
I was confident that members of the public who were in or around the finish line would have had video or still photographs of the perpetrators of this event. We felt with review and analysis of the videos that we could collect that we were going to get some pretty good photographs of the perpetrators here.
Citizens were outstanding. They were turning in their phones left and right to us to look at any video they had around that time of the crowd and their loved ones finishing. So the public response was great.
soon they are awash in photos and videos. But where to look? How to look? And what to look for?
We concentrated on the places where the bombs went off. Obviously, that was a key point of interest for us. And then we worked backward from there. Within a day or so, we identified an individual who was very suspicious. He appeared to have a package with him. He put the package down, and we realized that this is most likely the bomber.
Police say it's a smoking gun video that has not been publicly released. It shows a young man with a baseball cap worn backwards, leaving a backpack on the sidewalk not far from the second detonation site where 2 people died.
It's not exactly clear that it's a backpack initially, but later, you clearly see where he placed it, how he placed it there, and then how he walked away from the scene after the first detonation, and then you see the second detonation occur. It seemed like it was well rehearsed.
They focus on finding more images of the white hat suspect. And before long, he leads them to another man wearing a black hat.
You see black hat and white hat together, and you see them separate as they're starting to walk down Boylston Street. They both had what looked to be heavy backpacks. They both had baseball caps on. So we obviously drew the inference that these 2 were going to be primary suspects for us.
But what could investigators do with blurry, low-resolution images like these? How hard would it be to connect these faces with some names?
We are out of time.
Hollywood makes a computer technology called facial recognition look easy.
I need a name, folks.
You got it?
Marek Stefanski.
But when you face the facts,
Searching.
this law enforcement tool is not as easy as it looks in the movies.
I'll take it from here.
What is facial recognition? How does it work in the real world? Inspector Ken McKeel runs the Real-Time Crime Center for the New York Police Department. In late 2011, NYPD established a facial identification section to work in conjunction with its extensive surveillance program.
It's not a definitive science such as fingerprints and DNA, but this is good. Just basically, maybe we can get a lead. Maybe we can be pointed in a direction that this might be a possible person. Our software.
McKeel demonstrates using a scenario similar to Boston, a grainy surveillance image of a suspected terrorist surrounded by other pedestrians. First, they look for the best view of the suspect's face.
This image, as you can see, has the head a little turned. This particular head is down. There's really not much face, and we are looking for a comparison in facial recognition software is a frontal pose. This seems to be the best picture that we would utilize in this type of situation. So we would grab that picture, we cut and crop it.
But the technique only works if the person is squarely facing the camera, and this angle is not good enough. So they map out the suspect's face, placing crosshairs on several key features: ears, nose, eyes, chin, and mouth. Then they use sophisticated software to convert the slightly askew photo into a 3-dimensional image. And that allows them to turn the suspect's face directly toward the camera virtually.
Okay, so now we're using the frontal pose. It's called a normalization pose. We're going to enter it into the facial recognition software. So we want to use this probe image of an unknown individual against our gallery of known individuals. And we basically have close to 4 million images that we use within the NYPD.
These are just demo images, but in a real search, they use a database of mugshots of prior offenders. Potentially, they could use driver's license or passport photos, but they say they don't.
Now, we input it into our facial recognition software. We want to line up the eyes as best as possible. try to center it. And you can see, even though this picture is not aesthetically nice to humans looking at it, you can see that it can work within the software.
The computer matches the face from the surveillance photo to this mugshot. The perp turns out to be Detective Roger Rodriguez, sitting in the back row, watching his boss do the demo. This unit has analyzed almost 2,000 images, leading to nearly 150 arrests. In Boston, can this technology help identify the suspects, the men in the white and black hats? FBI agents run the photos through government databases, but they come up empty. The images are just not good enough.
We have some capabilities with the facial stuff, but in this case, it didn't help us that great. The FBI didn't know who these suspects were.
The technology is not that as sophisticated as it is on TV. In this instance, they just didn't have the visual that was going to get them the match.
The FBI decides not to release the surveillance photos to the public, partly because it might prompt the suspects to flee. But the internet abhors a vacuum, and social media soon takes on a life of its own.
There was an information vacuum. People were filling it. They were filling it with bad information.
Hundreds upload their own videos and images of the marathon. On the website Reddit, users pinpoint people they consider suspicious. Marking up photos, they circle people with backpacks, often with darker complexions.
So innocent people were being fingered for a horrible, horrible crime, and that was putting those people at risk.
At the height of the social media-fueled frenzy, the New York Post runs this cover, fingering two men as suspects. The two had nothing to do with the bombs. This is the dark side of crowdsourcing, an internet witch hunt.
What I think Reddit showed was that it's often not the wisdom of crowds as much as it is simply crowds. And wisdom or madness may emerge.
With innocent people being accused and no further leads, the FBI reverses course. It decides to release the pictures of the real suspects.
The downside is people might flee if they see it, but the upside is that you've got people who tried to, who killed people, who tried to injure hundreds of people, and they're still out there, and they're probably thinking about doing it again. And so you have a responsibility to the community as well.
There's pluses and minuses. A lot of people say if you put it out, they're going to flee. But at the same time, I think you're seeing, we put it out because someone knows these kids.
On Thursday, we decided that the best course of action to pursue would be to make these pictures public.
We were asking for the public's help here. Please, if you recognize these two, let us know.
Today, we are enlisting the public's help to identify the two suspects.
On Thursday evening, the FBI holds a news conference describing the two suspects and setting off an extraordinary chain of events.
They are identified as Suspect 1 and Suspect 2. They appeared to be associated. Suspect 2 set down a backpack at the site of the second explosion, just in front of the Forum restaurant.
Once the photos hit the web, computer scientist Marios Savidis springs into action. He leads a research team at Carnegie Mellon University that is developing the next generation of facial recognition technology.
The problem in the Boston case is that the image was so small that current technology cannot handle that low-resolution face. There's simply not enough information. So you have to employ super-resolution techniques and image enhancement techniques to basically, what we call, the computer has to hallucinate.
By hallucinate, Savidis means that the computer has to turn a few pixels from a blurry photo into a recognizable face. Savidis will feed the computer thousands of examples of different faces, each in very low and very high resolution. Over time, the computer identifies patterns and makes connections. it learns.
That's where computers can be smart, and that's where it can do things that our human brain cannot do. Because it can learn the relationship of what a low-resolution degraded face image is and what the high-res. And when you give it enough data to learn that relationship, then it can actually build an algorithm to extract a high-res face that you can feed into such systems to try to give you a match.
The best possible image, released by the FBI 3 days after the bombings, was this one. A very low resolution, poorly lit, but nearly full frontal image of suspect number 2, the man in the white hat.
So we'll click on the image, and this is what you're really seeing, and you really don't see a lot of facial structure. So we had to estimate where those landmarks are on the face.
Savides and his team plot 79 distinct points on his face. They feed the blurry image with the markings into their latest facial recognition program, or algorithm.
Our algorithm was able to enhance and extract this face from that.
Could this be the key to identifying one of the bombers? Before Savides could send it off to the FBI, he was overtaken by dramatic events. The public release of the photos and videos seems to flush the suspects out. In Cambridge, MIT police officer Sean Collier is shot dead in cold blood. Police say it was an aborted effort to steal his gun. Across the river in Alston, a Mercedes SUV is carjacked by 2 men, bragging they are the marathon bombers. They take the driver on a long, frightening journey at gunpoint.
He still doesn't know at this point, are they going to kill him? You know, are they going to take him with them? Are they going to let him go?
He provides the crucial breakthrough in the case when he gives the carjackers the slip at this Cambridge gas station. With his car and the suspects gone, he calls 911 and tells police that his Mercedes has been stolen by the Boston bombers and his cell phone is inside.
A black Mercedes SUV, carjacked from 816 Memorial Drive at the gas station in Cambridge.
How can police track down the car and the suspects?
911, where's your emergency?
Brad Berry handles 911 calls at the Emergency Services Center in Chester County, Pennsylvania. He can help you out even when you can't communicate.
With our new system, you have the opportunity to pinpoint the location and send help out.
Your phone transmits a digital fingerprint to cell towers in the area, and that information can be used to pinpoint its location.
These icons here are each of the cell towers. Typically, a cell tower has what's called 3 sectors. That's a set of antennas facing in a particular direction. The one lit up in pink here, this is the one that's communicating with the phone. So it's typically the one that's closest to the phone. That signal then gets sent to all of these other towers, and then we measure how long it takes to get to this tower, compare that to how long it takes to get to that tower.
Typically, a cell phone communicates through the closest tower, but the transmission is also picked up by a second tower, usually farther away. The signal arrives at the second tower nanoseconds after the first. Tracking technology plots the points on a map that would create that precise delay. The potential locations fall on a curve.
Between any 2 towers, a time difference is spelled out by a curve. So with just that single measurement between these 2 towers, all we were able to tell is that the phone is somewhere on this curve.
Using at least 2 other towers, they calculate a second and then a third curve. The point at which the 3 curves intersect is the location of the phone.
911, where's your emergency?
This is how 911 calls are located in seconds.
East of Westbourne.
But you don't even need to be using your phone for this to work. So long as it is on, it is transmitting and receiving data. In the marathon bombing case, the police used technology like this to track down the carjackers.
Attention units for an armed carjacking at a Cambridge. The black Mercedes SUV, Suspects are two Middle Eastern males, both suspects armed with firearms.
The result is a violent confrontation here, near the intersection of Laurel Street and Dexter Avenue in the Boston suburb of Watertown.
Shots fired, shots fired. Shots fired! We got plainclothes officers up there. Make sure you know who's shooting at.
Gunshots, just back and forth. Pop, 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 pop. Police officers just taking cover behind their car, running back and forth.
If there is any doubt that the carjackers and the bombers are the same men, it quickly evaporates when the suspects begin throwing explosives at the police.
They have explosives, some type of grenades. They're in between the houses now.
The residents in this densely packed neighborhood are petrified.
They're still shooting.
Oh my God.
My guess would be 300 rounds went off.
It was scary.
It was terrifying. We were shaking.
2 more blasts went off. The last one being the largest really lit up the neighborhood with an orange glow. There was white smoke.
That explosion was another pressure cooker bomb. But they also hurled smaller, yet still very lethal explosives believed to be pipe bombs. In this device, the pipe itself acts as shrapnel, and the tightly packed gunpowder leads to a powerful explosion.
We might have to evacuate.
Eventually, the suspects run out of firepower.
And suddenly, the first suspect starts running out towards the police, cuts across the street, was taken to the ground. The police had their foot over him, and that's when I heard one officer who was pointing the gun at him say, "You move, I'll blow your head off." That's when the Mercedes took off. He gunned it. You saw the bump when he ran over the guy, drug him about 20 to 30 feet.
One ends up dead, crushed when the second suspect runs him over while fleeing the scene in the stolen Mercedes. Until this moment, no one knows their names. The dead suspect is fingerprinted, and a government database spits out a name. Tamerlan Tsarnaev, a Chechen national living in Cambridge. Quickly, they identify suspect number 2 as his younger brother, Dzhokhar. It turns out Tamerlan is not unknown to authorities. In 2011, the Russian government notified the U.S. that Tsarnaev had become radicalized. FBI agents interviewed him and put his name on a federal terrorist watch list, along with more than 800,000 others. But it's reported that the name was misspelled and his birth date was wrong. And as a result, after Tsarnaev's 2012 trip to Chechnya, he was not flagged for another FBI interview. So, does this reveal flaws in the way the government manages its huge databases?
The problem was that the U.S. law enforcement agencies reacted in a small data mindset by using the exact name and trying to find an exact match in the database. Because the name was misspelled, they didn't find an exact match.
Perhaps the best-known example of big data is Google, which routinely points out misspelled words.
If law enforcement had used a Google-style big data analysis, they might have prevented Boston bombing from happening.
But is big data enough on its own?
There's no substitute for that human quality, that intuition, that ability for somebody to say, with all this noise, there's the signal. And then the tools can really come to bear to say, yeah, that is the signal, and let's give it to more detail on it.
Back at Carnegie Mellon, Mario Savides continues his facial recognition experiment, which is totally dependent on big data. With Dzhokhar Tsarnaev identified and high-resolution photos now widely available, Savides decides to test his facial reconstruction of suspect number 2. It is based on this extremely blurry shot and is generated using the artificial intelligence technique called machine learning. He compares it to a database of 1 million faces, including this high-res picture of the younger Tsarnaev. After factoring out women, non-whites, facial hair, and people over 25, he gets this result. The real photo of Zohar ranks number 20 in the list of possible matches.
Our work is at its infancy, but we're still blown away on how it works. This wasn't a random face. This actually fit the Boston suspect. So that was huge.
Huge, not because it identifies a single suspect, but because it provides leads for law enforcement to follow. But of course, once a subject is identified, you still have to catch him.
We need to expand the perimeter in 4 directions from 98.
As Friday dawns in Boston, that's exactly what police are desperate to do.
A 3-block radius from 98.
With Tamerlan Tsarnaev dead, his 19-year-old brother Zohar is on the run.
At least 2 blocks deep for now.
He ditched the stolen Mercedes about a half a mile from the shootout and disappeared.
Have the SWAT team with me here. They are to the front as well.
Boston and surrounding areas are locked down.
We are progressing through this neighborhood, going door to door, street to street.
The world is watching.
Watertown is on a lockdown. People are being asked to stay in their homes. Don't leave. Do not let anybody in your home.
Hundreds of police officers descend on Watertown streets and backyards.
We've been witnessing these police officers, Anderson, go door to door for about an hour now.
Hours pass, but still, suspect Zohar Tsarnaev remains at large.
Lock wired, and lock full forward on the rotor brake.
The Massachusetts State Police deploy another high-tech tool to help in the hunt. They launch a helicopter equipped with a powerful eye in the sky, a thermal camera.
It sees totally different kinds of light. Warmer things release more energy, cooler things release less. So what you see with a thermal camera looks like a black and white picture, but what it's actually made by are the differences in thermal energy.
Our eyes can see visible light, but that's only a small piece of the electromagnetic spectrum. There are other forms of light and energy we can't see, including infrared. This is the radiation produced by the motion of atoms in an object. The higher the temperature, the more the atoms move and the more infrared radiation they produce. An infrared or thermal camera can detect even subtle temperature differences. An object doesn't have to be hot to show up. In fact, anything that's above absolute zero, about minus 460 degrees Fahrenheit, emits some infrared radiation. Whether it's a cup of coffee or a glass of ice water. A flight over Boston shows just how powerful a surveillance tool it can be. Climbing to 6,500 feet, FLIR Systems engineer Jim Woznicka lowers the multi-camera rotating pod through the cargo doors.
So the finish line was right here.
In the infrared mode, you see Boston in a new light.
See that guy just disappeared there? Look at all the people that you can actually see in the shadows with the IR camera.
Human beings, warmer than the sidewalk below them, are no longer hidden in the shadows or at night. This camera is so powerful, Jim is able to see a cigarette butt from a mile away.
Just threw a cigarette out. It's amazing. It just stands out so much.
But this is not X-ray vision. The infrared light waves cannot penetrate walls, so the camera can't see inside buildings. And the powerful magnification creates another challenge.
These typically are like microscopes. The challenge here is often finding the specimen You have to be at the right place at the right time to see it. In the case of the Boston Marathon bombing, we had somebody on foot moving, we think, in Watertown, but may even get beyond Watertown. That starts to get to be a lot of real estate. And just where to use that tool becomes a challenge. And if that individual is just outside of that lens, then you're going to miss it.
Friday afternoon, as the hunt for Dzhokhar Tsarnaev continues, State Troopers Mark Spencer and Edward Mathurin are in the air responding to tips.
There was a steady stream of calls coming in, dispatch. They were sending teams out to, check something. Somebody saw somebody in their backyard. Somebody's heard some noise in the woods. And it is something you have to do. You have to basically check all these tips and calls.
Tango 3 to Sergeant Washington.
Hey, thank you. You can power down.
But after a day of searching, authorities are no closer to tracking down their suspect.
We do not have an apprehension of our suspect this afternoon.
The stay indoors request is lifted. We are asking the public to remain vigilant if you are out. Continue to be alert to suspicious activity.
People nervously emerge from their homes. On Franklin Street in Watertown, just a few blocks from where the Mercedes is abandoned, one resident notices something odd in the backyard.
He just got a 911 call from a lady basically stating that she has a boat stored out in her backyard and there was some blood on the canvas. You really don't have your hopes up. I wasn't really expecting too much, but as soon as we got on scene, we came up over the neighborhood, and Eric saw the boat sitting in the backyard, and I just swung the FLIR over to it, and it was covered with shrink wrap, not a canvas.
The thin plastic shrink wrap was not enough to obscure an infrared image beneath.
I got a perfect picture. I got incredible detail. I knew right away, that it was definitely somebody in the boat. They were actually looking at us as we flew over.
We detected a little bit of movement. His body is head is towards the back of the boat. He's lying on the side of that fence. Acknowledged.
I was pretty surprised that not only was there a person in the boat, but the definition and clarity that I got from the camera.
The side of the fence, the side of the boat he's on, is the fence side. We'll come back around with our more.
The infrared system was incredibly important. There is evidence that that person is injured and that person is moving about inside that boat.
The scene is chaotic again. I see a police helicopter up above. The police and SWAT teams took off in that direction.
Activity, the police, the vans, the cars, Aaron, they're speeding by, sirens blazing, they're moving quickly. Something is going on.
The report back, I am told, was that police have engaged the possible suspect and that additional units are there.
Assume a perimeter position on Arlington.
Police on the ground have surrounded the home. Fittingly, they are led by Boston Police Superintendent Bill Evans. He has little doubt who is inside the boat. Dzhokhar Tsarnaev, the man with the white cap. He also assumes he is heavily armed.
Previously he had pipe bombs, he had guns. Our biggest concern was, given the weaponry he had, we didn't want to move in until it was safe to do so.
Then someone fires a shot, which quickly leads to a barrage of gunfire.
I don't know what triggered the shot, but this was a dangerous guy in there, and no one knew what he had.
Everybody hold fire. Hold your fire.
I was screaming for everyone to hold their fire.
After a tense standoff that lasts nearly 3 hours, the 19-year-old emerges unarmed. The SWAT team rushes in.
Suspect in custody. Nobody used to come in the perimeter. It's still a hot scene.
The manhunt is over.
Good evening. The tweet just came from the Boston police, and it reads in all caps, "Captured. The hunt is over. Suspect in custody."
"5 weeks after the marathon no one will ever forget, Bill Evans is up early and on a run through the rainy streets of Boston. He looks back on a week that he says felt like one long day.
It was quite an emotional week for a lot of us. You know, let's hope in our lifetime we never have to experience anything like this again.
There is no doubt law enforcement will rely more heavily on high-tech tools. Maybe one day the technology will even prevent crimes. But many of these ideas raise serious questions and concerns about privacy and may offer more promises than they can deliver. And old-school cops like Bill Evans remind us it is still human beings that solve crimes.
I'm not a real CSI guy, you know what I mean? So technology has wide advantages, but what's key is the boot work by our officers on the street. Getting down on their hands and knees, what we've seen on Boylston, and painstakingly gather every little piece of evidence to put a bomb together.
Later that morning, Evans is once again on duty. This time as 3,000 runners, many of them wearing their marathon numbers, gather to run the final mile of the unfinished race.
40 days ago, you ran as individuals, but today all of us, we run as one.
They pause to remember those who died and then run through the rain amid tears and cheers. Evans is already making plans for next year, wondering how to keep the race safe without defeating the whole purpose.
Obviously, it's a soft target, and you know, it's sad. It's sad that it happened. But we're going to come back bigger, and we're going to come back stronger, and send the message that, you know, we're not going to be intimidated by the terrorists.
Major funding for NOVA is provided by the David H. Koch Fund for Science, supporting NOVA and promoting public understanding of science. The Corporation for Public Broadcasting, and by contributions to your PBS station from viewers like you. Thank you. The Boeing Company, and by This NOVA program is available on DVD. To order, visit shoppbs.org or call 1-800-PLAY-PBS. NOVA is also available for download on iTunes.